My dear students, in this video we are going to find the conditions that a line, given line, lies in a given plane. If the line lies in a given plane, what are the conditions to satisfied by the line and the plane? See, condition for a line to lie in a plane. See, the condition for a line r equal to a plus tb is a line lies in the plane r dot n equal to d. If the line lies in the plane r dot n equal to d, the conditions are a dot n equal to d. This vector, line vector a dot n equal to d and b dot n equal to 0. And the vector lies in the vector, parallel vector in the line b is perpendicular to the vector n, therefore b dot n equal to 0. Okay. These two conditions are called in normal vector form. So in vector form, the line r equal to a plus tb is given in vector form and a dot n equal to d is the plane. If the line lies in the plane, the conditions are a dot n equal to d and b dot n equal to 0. Now in the Cartesian form, if the line x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c lies on the plane ax plus by plus cz plus d equal to 0, then the conditions are the point x1, y1, z1 satisfies the plane ax1 plus by1 plus cz1 plus d equal to 0, and the direction ratios of the vector abc multiplying with the coefficients of a, capital A, capital B and c, a plus b into b plus c into c equal to 0. These two conditions are in Cartesian form and these two conditions are in, vector form. Using this idea, I am going to solve one problem now. Okay? Now, we are going to solve one problem. See this problem. Verify whether the line x minus 3 by 4 equal to y minus 4 by minus 7 equal to z plus 3 by 12 lies in the plane 5x minus z plus z equal to 8. We have to find out, check whether the line lies on the plane. We have to check it that the line lies in the plane. But the line and plane are given in Cartesian form. They are given in Cartesian form. Therefore, we are using that idea. The conditions are, if the line lies on the plane in the Cartesian form, the conditions are the line, the point should be satisfied satisfying the plane ax1 plus by1 plus cz1 equal to d or plus d equal to 0, whatever it may be. ax1 plus by1 plus cz1 equal to d or plus d equal to 0. And we have to check it, the point satisfies this equation. This is the first condition. x1, y1, z1 is x1, y1, z1 are x1 3, y1 4, z1 minus 3. So x1, y1, z1 are 3, 4, this is minus 3. See, is that minus of minus 3? This is the point x1, y1. The coefficients a, b, c are capital A, capital B, capital C are in the plane 5 minus 1, 1. 5 minus 1, 1. Capital A 5, capital B minus 1, capital C is the coefficient is 1. 5 minus 1, 1. That's substituting these values in the condition and d equal to 8. What is d? D equal to 8. We will check whether the point satisfies the condition. A is 5 into x1 3 plus b is minus 1 into y1 is 4 plus c, capital C is 1 into z1 is minus 3 equal to 8. D we have to find out. This is equal to what? 5 into 3, 15 minus 4 minus 3. So 15 minus 7, 15 minus 7, minus 4 minus 3 minus 7, 15 minus 7 is 8. So D equal to 8. So first condition satisfied. D equal to 8 we derived. Okay. So the line satisfies the points. The point satisfying the equation of the plane. Therefore, first condition is true. Second condition. What is the second condition? in AA plus BB, second AA plus BB plus C into C equal to 0. A is what is capital A 5 and A, this is the line having the direction ratios -4, -7, 12. That are A, B, C. So A, B, C are -4, -7 and 12. This is C. -4, -7, C is 12. So A is 5. Sorry, A capital A is capital A 5, small a is -4. Plus capital B -1 and small b is -7. Plus capital C is 1, capital D is 1, small c is 12. We have to check whether this is equal to 0. See, this is equal to -20, minus or minus, plus 7 and plus 12. See, 20 minus 19, that is equal to -1, which is, it should be 0, which is not equal to 0. It should be 0, but here we have -1, it is not equal to 0. Therefore, the second condition is not satisfied by the line. Therefore, the line does not lie on the plane. Since the second condition is fails, therefore, the line does not lie on the plane. That's all about the problem. The line does not lie on the plane because second condition is not satisfied. Okay? Next idea, condition for coplanarity of two lines. Two lines are given and we have to find out the condition for coplanarity of given two lines. Consider the two lines are equal to A plus TB is one line and R equal to C plus TD is another line. These are the two lines given to you and we have to find out the coplanarity, condition for coplanarity of these two lines. Suppose these two lines A vector and C vector are lying on a plane. Well, on these two vectors, A vector and C vector are the position vector of the 2 points lying on a plane. Suppose you consider this plane. In this plane, A is a point and B is another point. A is one point and B is another point. These are the 2 points. Sorry, you consider another point by C because A and C are the 2 points. The position vector of the point A, OA is A vector from the first line and C is another point on the second line. And there are B vector and D vector are parallel vectors to this plane. These 2 points lies on a plane and B vector and D vector are parallel to this plane. Suppose this is vector B and this is vector D. There are 2 vectors, parallel vectors, which are also parallel to the plane. A and C are the position vectors of the points capital A and capital C. So, the condition here B cross D, here the cross product of the 2 vectors B cross D is perpendicular to the plane. B cross D is perpendicular to the plane. These 2 points lying on the plane and B and D are 2 parallel vectors and they are perpendicular to the plane. Therefore, the condition is C minus A cross B cross D C minus A cross B cross D equal to 0. C minus A, because AC cross B cross D are perpendicular dot, sorry. C minus A dot B cross D equal to 0 because they are perpendicular. This is AC. CA is AC. OA minus OC. AC vector and B cross D are perpendicular. Therefore, AC dot B cross D is 0. That AC vector is nothing but OC minus OA. That is C minus A. This C minus AC and B cross D vectors are perpendicular. Therefore, C minus A dot B cross D is 0. This we have seen already in our vector equation of a plane passing through 2 points and parallel to 2 different vectors. That is C minus A dot B cross D equal to 0. This is vector form. Cartesian form, the condition for Cartesian form. Cartesian form is two lines of x minus x1 by b1, because b and d are two vectors. B1, b is the first vector. X minus x1 by b1, y minus y1 by b2 equal to z minus z1 by b3. So b vector direction ratios are b1, b2, b3, and the point A is x1, y1, z1. And the line, second line is x minus x2. C vector is x2, y2, z2. So x minus x2 by d vector d1 equal to y minus y2 by d2 equal to z minus z3 by d3. These are the two lines given in Cartesian form. If these two lines are coplanar, the condition is the determinant. What is, you know, C minus A dot B cross D equal to 0. This is equal to determinant form. C minus A dot B cross D is C minus A is OC minus OA. C minus A, x2 minus x1, y2 minus y1, z2 minus z1. This is C minus A. B vector is b1, b2, b3, and the d vector is d1, d2, d3. This determinant value is 0. This is the condition for two lines are coplanar for this Cartesian form. Cartesian form, this is x2 minus x1, y2 minus z2 minus z1, z2 minus z1. Okay. B1, B2, B3, D1, D2, D3, B cross D is this. This determinant form is 0. This is a condition for the Cartesian form of the equation. The two lines are given in Cartesian form, and the condition is the determinant value is 0, and C minus A dot B cross D is 0 is the vector form. That's all about the idea of coplanarity of two lines. Okay. Now I am going to solve one problem for the coplanarity of two lines, so that the straight lines are equal to 5a plus 7k minus 3k plus s times of 4a plus 4k minus 5k one line, and another line is r vector equal to 8a plus 4j plus 5k plus 3 times of 7a plus j plus 3k are coplanar, and also find the vector equation of the plane in which these two equations lie, two straight lines lying on. Okay, see, the straight lines are, two lines are given. In this, we know that the condition for coplanarity, you convert this into the Cartesian form. Condition for coplanarity is x2 minus x1, y2 minus y1, z1, and b1, b2, b3, d1 and d2, d3. Second line. This determinant value is 0. This is the condition. What is x2, y2, z2? Second, this is the vector C. So the second line, the point like x2, y2, z2 lying on the second line, that is 8, 4, 5. x2, y2, z2 is 8, 4, 5, and the point x1, y1, z1 lying on the first line, that is 5, 7, minus 3. this is x1, y1, z1 is 5, 7, minus 3, and b1, b2, b3 in the first line. Vector b1, b vector is b1, b2, b3. The components of b is 4, 4, minus 5. 4, 4, minus 5. And second d vector component d1, d2, d3 is in the second line 7, 1, 3. 7, 1, 3. Okay. You substitute these values in the determinant and check whether the determinant value is 0. If it is 0, the two lines are coplanar. For that, x2 minus x1, x2 minus x1, 8 minus 5, 3, 8 minus 5, y2 minus y1, 4 minus 7, z2 minus z1, 5 minus or minus plus 3, 5 minus or minus plus 3, b1, b2, b3, 4, 4 minus 5, d1, d2, 3, 7, 1, 3, and this is equal to determinant 8 minus 5 is 3, 4 minus 7 minus 3, 5 plus 3 is 8, 4, 4 minus 5, 1, 7, 1, 3, and we check whether this determinant value is 0. This is equal to 3 into 4 3s are 12, minus or minus 5 1 is plus 5. 4 3s are 12, plus 5, minus or minus plus 3 into exponential minus become plus 3. 4 3s are 12, minus or minus plus 7 5s are 35, and plus 8 into 4 1 is 4, and 7 4s are 28, minus 28. So this is equal to 17. 3 into 17, 51. 17 into 3, 51. This is, what is that, plus 3 into 47. 3 into 47. And plus 8 into 28 minus 28 plus 4 is minus 24. Simplification, you will get 51 plus 3 7s are 21, 3 4s are 12, 12 plus 2, 14, and this is minus 8 4s are 32, 3, 8 2s are 16 plus 3 19, 192, this is 141 plus 51 is 192, so this is 192 minus 192. So this is become 0. The determinant value is 0. The determinant value is 0. Therefore, the two lines are coplanar. Therefore, the two lines are coplanar. That's the condition. The determinant value becomes 0. Therefore, the two lines are coplanar. Okay, our next idea, find the equation of the plane in which they lie. We have to find out the equation of the plane. That is, what is x? We have to take any one of the point x minus x1 to find the equation of the plane in which the two lines lie. We will see again. Okay. Next, we have to find out the vector equation of plane in which the two lines lying. For that, we have to take any one of the vector, A vector or C vector, that is r minus A dot B cross D or r minus C dot B cross D. Both are correct because you can take any one of this point, either A or C. I will take A vector A, r minus A dot B cross D. A is x1, y1, z1. Therefore, x minus x1, y minus y1, z minus z1. R is xy, z. R vector is xi plus yj plus zk. Therefore, r minus A is x minus x1. Y minus y1, z minus z1. So that is, what is that? We will see x minus x1. x1 is what? 5. Y minus y1 is 7. Z minus z1 is minus or minus plus 3. And b1, b2, b3, 4, 4 minus 5. And d1, d2, d3, 7, 1, 3. You have to expand this determinant, you will get the equation on the plane. So that is equal to C x minus 5 x minus 5 into 12 plus 5. 4 3s are 12 plus 5 and minus of y minus 7 into 12 minus of minus plus 35 plus z plus 3 into 4 minus 28. 4 1 is 4 minus 28. This is equal to x minus 5 into 17 minus of y minus 7 into 47 plus, here plus z plus 3 into minus 24. So that is equal to, what is that? It is equal to 0, is it not? The minimum value should be 0. So equation becomes this x minus 5, 17x, okay? Okay, 17x minus 85 minus 47y minus of minus plus 7 7s are 49, 329 and plus minus 24 is that minus plus and minus 72, okay, equal to 0. So this is 17x minus 47y minus 24 is that, see, 85 minus 72 minus 85 minus 72, you get minus 157. You get 329 by minus 157, you get 172. 329 minus 157 is plus 172 equal to 0, and you take everything to the right hand side. See, minus 172, you will get 17x, okay, you keep as it is. This is the equation of the plane in Cartesian form. 17x minus 47y minus 24z plus 170 equal to 0 is in the Cartesian form, but in the question we are asking vector form. Therefore, instead of xyz you can replace by r dot 17i minus 47j minus 24k plus 172 equal to 0. R dot 17 x r will be xi plus yj plus zk 17x minus 47y minus 24z plus 170 equal to 0. This is the vector equation of the plane, and above equation instead of x, y, z you can replace I, j, k. It will give you the vector equation by taking r dot. So this is the Cartesian form of the equation of the plane. It will contain the four lines, these two lines. Similarly, the vector equation of the plane, it containing the two lines is r dot, this is equal to 0. So this is the equation of the plane, vector equation of the plane in which the two lines are lying. That's all about the problem, and I will stop my video here and we will continue the next idea in the next video. Thank you.